Hello students, in this video I am going to explain 20 multiple choice questions from the chapter The Solid State of Second PUC. So this will give you an idea to solve the questions appearing in competitive exams. Question number 1. Which of the following properties does not define a crystalline solid? Options: A. When cut into pieces have irregular surface. B. Isotropic in nature. C. Anisotropic in nature. And D. Both A and B. Let us see the solution for this. So crystalline solids, when cut into pieces, they have surfaces which are plain and smooth. And also crystalline solids are anisotropic in nature. So in these options, the options which are not defining crystalline solid are option A and option B. Hence, the correct answer is D, both A and B. Question number 2. Which of the following statements is true? Option A. Molecular crystals are very hard and incompressible. Option B. Ionic crystals have very low volatility. Option C. Metallic bond is directional and rigid. Option D. Boron nitride has an ionic crystal structure. Let me show the solution. So, ionic crystals have very high melting point and boiling points, hence their volatility is low. So, hence in these options, the correct option is option B. Option B is the statement which is true. Question number 3. Which of the following is a pseudo-solid? Option A. Calcium fluoride. Option B. Glass. Option C. Sodium chloride. And option D. All of these. Correct answer is option B. Glass. So, some glass objects from ancient civilizations are found to become milky in appearance because of some crystallization. Like liquids, amorphous solids have a tendency to flow very slowly. Therefore, they are sometimes called pseudo-solids or also called as supercooled liquids. Hence, the correct answer is B, glass. So, it is called as pseudo-solid. Question number 4. A cubic close packed structure contains n number of atoms. The tetrahedral and octahedral voids respectively will be option A n and n, option B 2n and 2n, option C 2n and n, option D n and 2n. Solution. In cubic close packing arrangement, there is one octahedral and two tetrahedral voids corresponding to each atom. Hence, correct answer is option C, 2n and n is the number of tetrahedral and octahedral voids respectively. So, you have to remember that in cubic close packing arrangement, there is one octahedral and two tetrahedral voids for each atom. Question number 5. A compound formed by elements A and B crystallizes in cubic structure in which A atoms are at the corners of the cube and B atoms at the center of the cube. Formula of the compound is option A, A2B3, option B, AB2, option C, AB3 and option D, AB. Let us see the solution. So here number of atoms of the element A per unit cell can be calculated. So like this, so 8 into 1 by 8. So 8 means 8 corners will be there for the cube. So 8 into contribution of each atom to the total number will be 1 by 8. So 8 into 1 by 8 give rise to 1. Number of atoms of B in one unit cell is equal to 1 because B is present in the center of the cube. So center of the cube only one atom will be present. Hence number of atoms of elements A and B per unit cell is 1 each. Therefore formula becomes AB. Hence correct option is option D, AB. Question number 6. In HCP arrangement, the coordination number is option A 6, option B 12, option C 8 and option D 10. Solution. So in HCP arrangement, usually coordination number is 12 because each sphere touches 6 nearest neighbors of its own layer, 3 of upper and 3 of lower. Hence total of 12. So therefore coordination number is 12. So correct option is option B 12. Question number 7. A solid has a BCC structure. If the distance of closest approach between the two atoms is 1.73 angstrom, the edge length of the cell is A 200 picometer, B root 3 by root 2, C 142.2 picometer, D root 2 picometer. Let us see the solution for this. So nearest neighbor distance D is equal to 1.73 angstrom. For body centered cubic arrangement, D is equal to root 3 by 2 into A. So where A is equal to edge length. So you can arrange this equation for the A. So A becomes D into 2 divided by root 3. So here D is, that is nearest neighbor distance is 1.73 into 2 divided by root 3. On simplifying, we will get the value of A, that is 2 angstrom, or you can write it as 200 picometer. Hence the correct option is option A 200 picometer. Question number 8. Lithium metal crystallizes in a body-centered cubic crystal. If the length of the side of the unit cell is 351 picometer, the atomic radius of lithium will be option A 151.98 picometer, option B 75.55 picometer, option C 300.05 picometer and option D 240.80 picometer. So let us see the solution. So here they given that lithium crystallizes in body centered cubic arrangement. Hence atomic radius we can write it as R is equal to root 3 by 4 A, where A is equal to edge length of the unit cell. So R is equal to root 3 by 4. Substitute the value of A 351 picometer. So simplify, you will get the value of atomic radius of lithium, that is 151.98 picometer. Hence correct option is A 151.98 picometer. Question number 9. The edge length of the unit cell of sodium chloride crystal lattice is 5.623 angstrom and density is 2.16 gram per centimeter cube and molar mass of sodium chloride is 58.5 gram per mole. The number of atoms per unit cell is option A 4, option B 3, option C 1 and option D 2. Let us solve this one. So we are having density formula, that is D is equal to Z into M divided by A cube Na, where Z is the number of atoms, M is the molar mass of the crystal and A is the edge length of the unit cell and Na is the Avogadro number. So you can rearrange this equation for Z. So Z becomes equal to D into A cube into Na divided by M. So here substitute all the values. So density is given, that is 2.16 and Avogadro number is 6.023 into 10 to the power 23 and value of edge length is given of unit cell, that is 5.623 into 10 raised to minus 8, its cube, then divided by M molar mass. So that is 58.5. So substitute all the values, simplify. So you will get an answer of 4. Hence correct option is option A 4. Number 10. As a result of Frenkel defect, option A, there is no effect on the density. Option B, there is no effect on conductivity. Option C, there is no effect on dielectric constant. And option D, there is no effect on the all of the above. So Frenkel defect means, in the Frenkel defect, ions get displaced from their original position and move to interstitial site. So there is no change of density because they only move from their original position to the another position, that is interstitial site. Hence the correct option is option A, there is no effect on the density. Question number 11. The flame colors of metal ions are due to option A Frenkel defect, option B Schottky defect, option C metal deficiency defect, option D metal excess defect. So let us see the solution. So the flame colors of metal ions are due to metal excess defect. These crystals are usually colored. It is due to the presence of free electrons. So these electrons get excited easily to higher energy levels by absorption of certain wavelengths from the visible light, and therefore the compounds appear colored. Hence the correct option is option D, metal excess defect. Question number 12. In a solid lattice, the cation and anion both have left a lattice site. The lattice defect is known as A. Interstitial defect, B. Valency defect, C. Frenkel defect and D. Schottky defect. So, equal number of cations and anions leave the lattice site in Schottky defect. So, here in the question, the cation and anion both have left lattice site. That means equal number of cations and anions are leaving the lattice site here. Hence, the correct option is option D, Schottky defect. Question number 13. In a ferromagnetic material, option A, all the magnetic moment vectors are aligned in one direction. Option B, half of the magnetic moment vectors point in one direction and rest in opposite direction. Option C, all the magnetic moment vectors are randomly oriented. Option D, small magnetic moment is present. So in ferromagnetic material, all magnetic moment vectors are aligned in one direction such that these substances will show magnetic properties even in the absence of external magnetic field. Therefore, the correct option is option A. All the magnetic moment vectors are aligned in one direction. Question number 14. 0.005 centimeter thick coating of silver is deposited on a plate of 0.5 meter square area. The number of silver atoms deposited on the plate is dash. So atomic mass of silver is given 108 and density is given 7.9 gram per centimeter cube. So option A 1.1 into 10 raised to 10. Option B 1.1 into 10 raised to 15. Option C 1.1 into 10 raised to 24. And option D 1.1 into 10 raised to 30. Let us solve this one. First you have to calculate volume of silver deposited. That can be calculated by multiplying area of deposition with the thickness of coating. So area of deposition is 0.5 meter square. So convert it to the centimeter scale. It becomes 0.5 into 10 raised to 4 centimeter square. On multiplying, you will get volume of Ag deposited, that is 25 centimeter cube. So in the next step, mass of Ag deposited can be calculated by multiplying volume with the density. So number of Ag deposited is equal to volume into density divided by 108, that is atomic mass of silver, into Avogadro number, that is Ne. So 25 into 7.9 into 6.023 into 10 raised to 23 divided by 108. So answer is 1.1 into 10 raised to 24. Hence correct option is option C. Question number 15. Potassium has body-centered cubic structure with the nearest neighbor distance 4.52 angstrom. Its atomic weight is 39. Its density will be dash. Option A 454 kg per meter cube. Option B 804 kg per meter cube. Option C 852 kg per meter cube. And option D is 910 kg per meter cube. Let us calculate this one. So we know that for body-centered cubic system, radius of atom can be given by r is equal to root 3 by 4 into a. So where a is the edge length of the unit cell. So here nearest distance is given, that is neighbor distance. So neighbor distance is nothing but 2 into atomic radius, that is 2r, equal to 4.52 angstrom. So first equation you can rearrange for A. So A becomes equal to 4 into R divided by root 3. So here 2R is given. So 4R can be calculated by multiplying 2 into 2R. So 2 into 4.52 give rise to 4R divided by root 3. So answer is 522 picometer. So that is A, value of edge length. So in the next step, you can calculate density by using the formula of Z into M divided by A cube into Na. So where Z is the number of atoms, M is the atomic weight of potassium divided by A is the edge length and Na is the Avogadro number. So substitute all the values. So Z is 3 because here body centered cubic system. Total number of atoms will be 2. Then atomic weight of potassium is 39. Then A is 522 picometer. So converting into meter it becomes 522 into 10 raised to minus 10. And then you substitute for Na, that is 6.02 into 10 raised to 23. On simplifying, you will get value of density, that is 0.91 gram per centimeter cube or 910 kg per meter cube. Therefore, correct option is option D, 910 kg per meter cube. Question number 16. The crystal system of a compound with the unit cell dimensions A is equal to 0.387, B also equal to 0.387 and C is equal to 0.504 nanometer, and alpha is equal to beta, which is equal to 90 degree, and gamma is equal to 120 degree is option A cubic, option B hexagonal, option C orthorhombic, option D rhombohedral. So these parameter, that is A is equal to 0.387, B also is equal to 0.387 and C is different and alpha and beta are same and gamma is 120. So that parameters are representing hexagonal system. So you have to remember, for hexagonal system A equal to B and not equal to C, and alpha is equal to beta which is not equal to gamma. Hence correct option is hexagonal, option B. So this is direct question. You have to remember these parameters. Question number 17. The number of unit cells in 58.5 gram of NaCl is nearly dash. Option A 6 into 10 raised to 20. Option B 3 into 10 raised to 22. Option C 1.5 into 10 raised to 23. And option D 0.5 into 10 raised to 24. Let us solve this one. So 1 mole of NaCl is equal to 58.5 gram and it must contain Avogadro number of particles. Hence it contains 6.023 into 10 raised to 23 atoms. So here FCC contains 4 atoms per unit cell. So the number of unit cell is total number of atom divided by number of atoms per each cell. So total number of atom is 6.023 into 10 raised to 23 divided by number of atoms per unit cell is 4. Hence on dividing these two we will get the number of unit cell. So that is 1.5 into 10 raised to 23. Hence the correct answer is option C, 1.5 into 10 raised to 23. Question number 18. The material used in the solar cells contains dash. Option A carbon, option B silicon, option C sulfur and option D titanium. So silicon having semiconductor properties is used in solar cells. So you have to remember this. Silicon is having property of semiconductivity, hence it can be used for solar cells. So here our answer is option B, silicon. Question number 19. Quartz is a crystalline variety of dash. Option A, silicon carbide. Option B, sodium silicate. Option C, silica. And option D, silicon. So quartz, it is a naturally occurring crystalline form of silica. So silica is nothing but silicon dioxide. So hence correct option is option C, silica. Question number 20. Certain crystals produce electric signals on application of pressure. This phenomena is called dash. Option A, pyroelectricity. Option B, ferroelectricity. Option C, piezoelectricity. And option D, ferrielectricity. So piezoelectric substances produce electric signals when mechanical stress is applied to them. Hence correct option is option C, piezoelectricity. Thank you.